Last lecture, in last lecture we have seen the working principle of DC motor as well as Fleming's left hand rule. With that, we have gone through the back EMF, how it is going to generate, and the significance of that back EMF. So now we will see the voltage equation. Okay, so voltage, is my screen visible to all? Screen दिसते सगळ्यांना? Okay, so now voltage equation, in that, see, here is the uh, see, this is the figure of the DC motor. So in that figure there is a shunt field, this is an armature, back EMF is there, EB. Also we know that voltage is appear across this, or voltage is applied across this motor. So ISH, that is shunt current flowing through the field winding, whereas the armature current flowing through the armature. So total I is equal to IA plus ISH. Okay, now first thing, you can see the direction of arrows of V and the EB. You can see these are the opposite in direction of each other. So here, whenever the voltage V applied across the motor armature, which has to be overcome the back EMF and the supply armature ohmic drop. Now we know that there is a voltage drop in an armature circuit, which is nothing but IaRa, that is armature current multiplied by the armature resistance. So we know that V is equal to, so that V voltage is equal to that back EMF plus whatever the drop in that circuit, that is IRA. So equation will become V is equal to EB plus IaRa. Okay, so this is the voltage equation of a motor. Okay, this is the voltage equation. Okay, in case of DC generator, we are generating the EMF, that's why it is known as EMF equation. But here back EMF is generating, and we need to know, find out the total voltage of the motor whatever be supplied. So that's why it is known as a voltage equation, and it equal to V is equal to EB plus IaRa, that is to overcome the back EMF plus armature ohmic drop, that is armature voltage drop. Okay, so now if we multiply by the armature current for the both sides, it will become VIa is equal to EBIA plus IA square RA. ओके, सो काय केलं आपण, दोन्ही बाजूला आर्मेचर करंटने मल्टिप्लाय केलं. सो इफ विल डू दॅट, then that electrical input to the armature, which is equal to VIA. So voltage into current is nothing but power. So that's why we can say V into IA, which will be the power input of electrical input to the armature circuit. Then EBIA. EBIA means what? That back EMF multiplied by the IA, that is nothing but mechanical power developed in the armature circuit. And Ia square Ra means what? Ia square Ra we have already seen in a DC generator, which is nothing but the copper losses in a armature, that is Ia square Ra. Okay, so now if we consider that some losses is vested, that is I square R, then rest of all energy is converted into mechanical power in the armature circuitry. Okay, so that is why the motor efficiency is also known as the power developed, or ratio of the power developed by the armature to its input. So we know that power developed by armature is nothing but EBIA. Okay, power developed by the armature is nothing but EBIA, and power input or electrical input to the armature is VIA, V into IA. So ratio will become EBIA divided by VIA. So IA will become cancel here, and only the term will remain, that is EB divided by V. So that means higher the value of a back EMF as compared to the voltage, then it will be the higher motor efficiency. म्हणजे जितकं जास्त व्होल्टेज पेक्षा बॅक ईएमएफ जास्त असेल तितकी तुमची इफिशियन्सी ही जास्त असणार आहे. ओके, सो दिस इज ऑल अबाउट द व्होल्टेज इक्वेशन ऑफ द डीसी जनरेटर, सॉरी डीसी मोटर. ओके, सगळ्यांना क्लिअर आहे? एनी डाऊट? Any doubt? I hope you understood that one. Okay, so we'll go for the next one is a torque equation. Okay, so now this is very important. As we have seen in the assignment question booklet, there is a 6 marks, 4 marks, 5 marks questions which asked in examination, university examination for 3 times. So this is an important part or important question. Okay, so see, first thing that the term torque is nothing but the turning or twisting moment about an axis. Okay, now consider this is the pulley. Okay, in that figure you'll consider this is a pulley which having the small r radius and the force which is applied here. Okay, and that is rotating in this direction. Okay, this pulley is rotating in that direction where this force is here. Okay, and this pulley having the radius of r. Okay, now the torque which is measured by doing or by measuring using the product of force and the radius at which that force is going to act. Okay, so how this torque is going to calculate? The calculation of torque is a very simple by doing the multiplication of the force and the radius at which that force is acting. म्हणजे टॉर्क फाइंड आउट करायसाठी काय इक्वेशन आहे, तर जे काही तुमचा फोर्स आहे तो फोर्स आणि ज्या रेडियसला तो फोर्स ऍक्ट होतोय दॅट रेडियस. ओके, सो दॅट मीन्स suppose we will consider that a pulley which having the radius r and acted upon by a circumstance force of a f newton. Okay, so force is measured in a newton which causes it to rotate at the air. As we know that the torque is measured by product of the force and the radius where that force is acting. So we know that T is equal to force is denoted by F and the radius is denoted by R. So T is equal to F into R. You can see here, and the unit is Newton meter. Okay, unit is Newton meter. Now we have to find out the work done by this force in one revolution. Means what? एका रिव्हॉल्युशन मध्ये किती वर्क केलं जातं, किती वर्क या फोर्समुळे किती काम केलं जातं हे फाइंड आउट करायचं. ते कसं फाइंड आउट करणार, तर तुमचा जो टोटल फोर्स असेल तो फोर्स मल्टिप्लाय बाय दॅट फोर्स मल्टिप्लाय बाय डिस्टन्स इनटू एक रिव्हॉल्युशन पूर्ण करणे म्हणजेच काय, याला आपण काय म्हणू शकतो, 360 डिग्री. दॅट इज नथिंग बट 2 पाय इंटू रेडियस. So we have to calculate area of the circle, that is f into 2 pi r. Okay, how much distance is that? R into 360, that is 2 pi. Okay, so the total work done by this force in a single revolution will be force into distance, that is f into 2 pi r. Now we have to calculate the power developed. Okay, so how we will calculate that power? That power will be equal to that work done into whatever the speed is there. Okay, so f into, just a moment. Okay, so power developed is equal to f into 2 pi r. Why this f and 2 pi r we are taken? Because this is the equation for the work done, and into n, that is a speed. So f into r is into 2 pi n, watt is nothing but power developed. Okay, so now we know that 2 pi n means what? एवढ्या स्पीडने 360 डिग्री मध्ये फिरणे, that is nothing but angular velocity, and that angular velocity which is denoted in omega. So we will replace 2 pi n by the omega. Okay, and we know that f into r is nothing but what? F into r is torque. So we will replace that f into r by t and 2 pi n by the omega. So we will get the power developed is t into omega. So p is equal to t omega. Okay, t omega. Okay, so if we know that speed is an rpm, that is a revolution per minute, then that omega is equal to 2 pi n divided by 60. Why this is doing? Because we need to convert that rpm to rps. So whenever we have to convert that rpm to rps, we need to divide by 60. So 2 pi n by 60 into t, because this w is replaced by this value 2 pi n by 60. So this p is equal to 2 pi n by 60 into t. Now we know that 2 pi by 60 into nt. So 2 pi by 60 we can calculate, it will become 1 upon 9.5. So torque equation will be like that. So power developed will become to nt divided by 9.55. So n is nothing but speed in rps, t is nothing but torque, and 9.55 is a constant variable, oh, sorry, constant value, numerical value. Okay, so this is the torque equation. Okay, so for today we will stop here. Okay, so next lecture we will go for the further losses as well as DC motor types. We will revise all the things which we have learned today in next lecture also. Okay, so for now you have one homework, that is one question: derive the torque equation of DC motor. So you should write that question. Okay, so I will share the screenshot of the assignment questions on a group. So you start immediately to write the question on your separate assignment booklet or separate assignment book notebook. Okay, there should be a separate notebook for the assignment. So you should write a first question for the second assignment DC motor, and I will share on the 14th or in 1 or 2 day. That is the assignment number 1, that is about DC generator, and assignment number 2 about DC motor I will share you soon. Okay, so for now we will stop here. You just do a study. Okay, so have a great day.